Hello there, my name is Gregory Carlson and we're learning about college algebra. This is section 1.6, which I just call solving tricky equations because we're just going to learn a few tricks here to solve some more difficult equations. But first, let's talk about equations. So far we've just been kind of learning the basics and we haven't had any reason to worry about this. But from now on, there are some restrictions on what we can plug into an equation. There are some restrictions on what we plug in for x, or whatever your variable is, that is not allowed. And anything that we can plug into an equation belongs to a set of numbers called the domain. So the domain is the collection of all of your inputs that you're plugging into the equation. So there are some restrictions on the domain. And we'll talk about this more later, but the first big restriction is in an equation, the denominator of a fraction can never equal 0. So if we ever do have a fraction where the denominator is equal to 0, so for example 3 divided by 0, then we say that that fraction is undefined. We do not have a definition of that, and so it's not really a number, it doesn't have a definition, it's undefined. So we can never have a denominator be 0, and in class we'll spend some time looking at why that is in more detail. So check out this problem. We have 3 over 2x minus 4 plus 2 over 5x minus 11 is equal to 21. So you can see here that I have x in the denominator of a fraction. So that means it's possible that x could be something that makes the entire denominator be 0. That would be bad. So it wants to know what values are not possible solutions of these equations. Basically what it's asking is what values for x will make either one of these denominators be 0. And so we can solve that by saying 2x minus 4 equals 0, and 5x minus 11 equals 0. And solving these two equations would tell us what values of x make either of these fractions have 0 for their entire denominator. It's worth noting that in this case, x can be 0 itself. X can be 0 so long as the entire denominator isn't 0. So here we go. Add 4, 2x equals 4. Divide by 2, divide by 2. So our first thing that x cannot be is x equals 2. Because if x equals 2, we get 2 times 2 is 4. 4 minus 4 is 0. And that would make this fraction, as you can see, be undefined. Solving this one, 5x equals 11, divide by 5, divide by 5. X cannot equal 11 over 5. Because if it did, then this denominator would be 0, and that would be undefined. So I'll go ahead and put slashes through these equal signs because x cannot equal those two values. And when we're doing problems, we need to keep track of things like that. This equation will have a solution, but I'll show you how to find that solution when we get to this problem. So look over here. On your own, see if you can figure out what values x cannot be in this equation. If x was one of these, it would be undefined. See if you can get it. Hopefully you paused the video and got the answers. You just set each fraction denominator equal to 0 to find out what values x can't be. You also, if you're good at this, might be able to just do it in your head. If you look at this, it's obvious that x can't be 4, because if it was, 4 minus 4 would be 0. So x can't be 4. On the next one, we have x plus 3, so x can't equal negative 3, and x can't be 0. So here are the three values that x cannot be in this equation. Those would be restrictions on the domain, restrictions on the inputs of the equation. But how would we actually solve one of these? So in this problem right here, they actually want us to solve this equation. And here's our equals sign. So gosh, look at this thing. This thing is brutal. Look at all of these m's. We have a polynomial, a polynomial, a polynomial. Luckily, it's not too difficult to solve this equation, but I'm just going to show you the general strategy for it. So here we go. The first thing to do is to factor. You want to factor all three of these denominators. So they're all trinomials, so let's factor them. I'm going to do this kind of quickly. Two numbers that multiply to make negative 24 and add up to 2. That'll be x plus 6, x minus 4. Actually, I should be using m's, huh? Sorry about that. All right, so m plus 6, m minus 4. I need two numbers that multiply to negative 20 and add up to positive 1. That would be m plus 5, m minus 4. And two numbers that multiply to 30 to add up to 11 will be m plus 5, m plus 6. You should practice this until you can do that as fast as I just did it. Okay, so what we just did is we just rewrote each of these denominators. By the way, let's go ahead and point out the values that m can't be. M can't be negative 6, m can't be 4, m can't be negative 5. If m was negative 6, this denominator would be 0. If m was 4, that would be a 0, which would multiply to make the whole thing be 0, which would be bad. We already got 4, can't be negative 5, and we got both of those. So here are three values just off to the side that m cannot be. So how do we do this? What you're going to want to do is multiply by the greatest common multiple of all of these. And I'm just going to tell you what it is, and you'll see why this works in a second. We're going to want to multiply each fraction by m plus 6, m minus 4, m plus 5. We're going to multiply the entire equation by this amount, which means multiply every term by this amount. And at first, this looks terrifying, because look at how much I'm multiplying by. So I'm multiplying the entire equation by this amount, m plus 6, m minus 4, m plus 5. Now, and that means I'm multiplying all three by this. Now, where did I come up with that? I'm multiplying this by something that's going to cancel all of the fractions. That's going to cancel all of the denominators. And so I noticed to do that, I need an m plus 6 piece, I need an m minus 4 piece, and I need an m plus 5 piece. And so if I take those three and multiply them together, it's going to cancel this fraction, cancel this one, and cancel this one. So watch how that's going to work. It really makes it nice and simple. So on the first term, m plus 6 cancels, m minus 4 cancels, so I'm just left with m plus 5 and a 5. Because I'm multiplying, it just breaks up into 5 times m plus 5. Easy as that. On the next one, m plus 5 cancels, m minus 4 cancels, so I'm just left with m plus 6 times 2. And on the last one, m plus 5 cancels, m plus 6 cancels, so I'm left with 5 times m minus 4. And look at how nicely that's simplified. Isn't that wonderful? We got rid of all of our fractions and just have one term each. Don't even have a quadratic here. So just to recap, where I got these three terms is I picked things that would cancel all the denominators. So now we can just solve this pretty easily. Distributive property, 5m plus 25 plus 2m plus 12 equals 5m minus 20 from the distributive property. Add like terms over here, 7m plus 37 equals 5m minus 20. That's 7m plus 37 equals 5m minus 20. I'm trying to find a good place for this where it's not in the light so much. Anyway, let's just finish it up. Minus 5m minus 5m. So I get 2m plus 37 equals negative 20 minus 37. 2m equals negative 57, and then divide by 2, divide by 2. M equals negative 57 over 2. Let's check that against the three things that we know m can't be, and we see that our answer is not on the list, so boom, we are done. And if you wanted to check your answer on this, I would convert this to a negative decimal, and then plug it into the original equation for m, and when you do that, the left side should equal the right side. So this is not nearly as bad as it looks. If you figure out the right thing to multiply by, it simplifies the problem very nicely. So that's how to solve one of these where we have these huge polynomials in the denominator of a fraction. I think we've hit 10 minutes, and so I will see you in part 2.